Okay, part 4 of the 3D pocket sample part on finishing. I still have my projections turned on. I'm going to turn them off temporarily. So I did OD contour, and then these little flats there. So the outside is totally done. So we need to just do this inside. This is a flat area, so this would be a pretty simple contour selection. So this one we just selected this boundary with no additional cuts. So we did model top, model top, model top, model top, and selected contour again. With nothing fancy. We're using our presets in our tool library, so we're running 8,000 RPM with 2,000s per tooth, which gives us 48 inches a minute for the cutting rate. So that's a pretty simple one. And the chamfering is going to be pretty simple, other than I'm starting to label these so I don't get lost. I might even label this like inside contour, outside contour. So in this one, this is pretty simple chamfer, that edge and this edge. And on chamfering, we always use 0 for chamfer width if you're aligning to the chamfer. If down here, if it has no chamfer, then we're going to add some. All right, this is chamfer step. Let me zoom out here. And that's down here. This is also has no modeled chamfer. Let's check the setting on that. So we added 10 thousandths for width, so to get a little bit of a chamfer. It may even be a little bit heavy. I'm going to change this to 0.005. So we just want an edge break, they call it, just or for deburring purposes. So there's a lighter cut. And I labeled this one chamfer flange. I was just trying to label these. And hit edit. Use the chamfer preset geometry, pretty much just selecting that area only. And selected contour for our heights. And only 5 thousandths here, but make sure you have chamfer clearance on because we're going to become close to these walls. In order, so you don't crash into that. So it won't go all the way, it'll get pretty close though. That takes care of all the chamfering. Then we'll just go simple spot drill here. We have spot drill. And we got the drill cycle on. We selected the hole faces and we do the same diameter. So we don't have to select all of them. And I did to chamfer width, which meant to the model of the chamfer. So it just went to match that, match the hole. Now if you wanted to get a little bit more, we could put in to chamfer diameter, which you can put in a hard number. Or this one would be the same thing, chamfer width, so put 0.005. Okay, that should go in a little bit deeper. We'll check on simulation. And then we did a dupe. In a lot of these operations you can duplicate, like duplicate the operation, change the tool. So we did, we got a drill out of the, because it wasn't in our tools, we had to go in the Fusion library here, and we went to the sample tools under inch, and went to hole making, found a drill that was the correct size. We just went through the diameters here. We just label. You can actually sort by size if you want to do that. And I found a 0.250 drill right here. I clicked on this. It had some feeds and speeds already in here, so I clicked aluminum drilling. That's where this came from. So I selected the holes, but we want this to be drilled through. So my height selection was hole bottom, drill through bottom, and I'm going to add in 0.010 just to make sure we broke through. And I have this as feed height as hole top because if you do it from up here, it's gonna feed, and then finally get down to here. So just gotta make sure it's clearing up here. So I got model top, then feed height and top height, or whole top. And we're going to the bottom, drilling through. And it actually used another cycle called chip breaking partial retract. This will give you a G73 cycle versus the G83 cycle. So it's a little faster drilling. And I used a pecking increment here. So one rule of thumb could be make the pecking increment equal to the diameter of the drill, or diameter divided by 2. That's a pretty good one. This is probably smallish right there. All right, so really what we want to do is, how do we do the finishing on this? So actually when we did this, we tried a couple profiles. We went to the cam sample library. Now this is in the Fusion 360 cam samples, which can be found right here, samples under cam samples. We also have it in our Partmaker library here in the 3-axis section under tutorials. But this is a sample of different 3Ds here. It's like a buffet. So this is parallel. And then you can read a little bit about it, I believe, by pressing on the help button and show learning panel. So I think if you pick the operation, or you pick the operation from up here, and this will actually turn on a learning panel right here, which gives you a little bit more information. Cancel, close. But anyway, I can kind of like look at this and say, okay, I can see where there'd be issues here. And if we tighten it up, it may or may not be able to machine all that. That's parallel. But I actually learned something by looking at this. This is parallel also, only this is at an angle. And that looked like it would work well. So I can compare the two on the settings here. I see the boundary that's selected. It says selection, machine boundary chain, heights, passes, and this says 45 degrees pass direction. So that looks like the only difference between the two. And this one says machine steep areas. So I had to kind of look at this, and I see in this area it's got more cuts, and this is pretty much straight up and down. This has an angle, and that has an angle. So parallel with machine steep areas. So I just kind of look through this, and I kind of look at the settings, and I'm trying to look for right there, machine steep areas. So that's the selection there. All right, parallel. I heard parallel, contour, and scallop are like your go-tos. All right, this is contour, and in some other brands they call it waterline. If you think of waterline in a boat, so this it does the side well, but not the top very well. All right, so and this one has machine shallow areas. So this one does pretty good, other than not right here. And this is ramp, kind of the same. I'm going to go to scallop. Scallops seem to be pretty good. That seemed to cover everything. And spiral. Spiral's getting to this area. So I think we're kind of maybe in this area. Spiral or radial. That's a pretty cool looking one. Or morph spiral. So these selections are all in this area right here. Parallel, scallop, contour, ramp, pencil, horizontal, spiral, radial, morph, spiral. And it gives you some descriptions there. Morph and flow. Yeah. All right, so back to this here, the sample. So I'm actually going to just, let me update this one. I hate seeing the red buttons. Generate. Okay. I do have scallop in there now, but what I did was actually just tried some out. So I just did, let's do parallel. Let's just go right down the list. And I selected a 1/4" ball. This has to be done all with ball end mill. I'll go to milling and ball end mill only. And I have a couple of, I have 1/2 inch, 3/8, 1/4 inch, 3/16. I'm going to go right to 3/4, and I have 2 settings here. I'll get into that later. I'm going to just use fast contour. Hit select. My RPMs are all set. My feed rate at 3.5 thou per tooth. Geometry. So what do I select here? So I'm trying to see what it'll select. Like, can I select that area? Everything inside that area. That looks like it all needs machining. Tool containment. I have 3 selections. Tool center. And my heights, passes, and you have something here called step over, and that's what I have in my preset. My step over is on the rough side, coarse. And then we're just going to see what we get here. So this looks pretty good. So I'm actually going to move this scallop operation down to here. And I'm going to do simulate again. I'm going to take it step by step. 1, 2, 3, move this out of the way. 4, 5, 6, 7, 8 on my chamfering. Right now we're into drilling. So now I get drilled holes. Now I'm going to do parallel. Let's see how that goes. Looks like it's going to take a while, and it's not cutting where it shouldn't. I'm actually going to speed up and hit the ball there. Takes a little regeneration time, and actually went right in the scallop. So you notice these areas are still blue, and these are kind of rough looking. I tried to inspect the curve. I could not. I think just going on that, I think we need a smaller radius tool. But let's look at the simulation again. We bail out of this and hit parallel. And it should give me a picture of the part. Right? If I click this, there we go. And I notice right here it's kind of rough looking. I don't see a lot of cuts here. It actually looks like it's jumping up and over. So I don't think, even if we went 45 degrees, just to change the angle there. 45 degrees. Hit OK. And doesn't, well, I don't know, maybe it doesn't, yeah, it does, it looks kind of jumpy there. So I don't think that's good. Well, let me try smaller tool. I'm going to get out of this one, go into my milling, ball end mill, and I'm going to use my 3/16 tool, fast contour. Hit select and see what we get now. Hit OK. Alright, let's take a look at everything. Looks like turn that on again there, parallel. And I want to get it with the material. I can see it going up and over here. I don't know, it looks better-ish. Let's simulate again. Jump ahead, jump ahead. Alright, drill, parallel. Let's see how that goes. Got to give it some simulation time. Or not. Oh, I can see the 45 degree cut. Okay, wow, it's an improvement. It actually got everywhere, but I don't really like those lines. So it's still got scallop in there. So scallop's actually kind of making it work afterwards. Hit close, so parallel, not that good. All right, then we tried contour. I tried contour, I'm gonna stick with the smaller ball end mill. I'm just gonna hit OK and see what we get. Alright, so contour, it looks like I have to change some of these settings here. Alright, step down, cutting radius, flat area detection, order by depth. I don't think this is a very good machine shallow areas. Let's try that one. Okay. A little better, but I don't. Maybe if I did it with another tool, but I'd like to get the 1-2 to do all of it because it would look better. Contour, not a good selection. All right. I did horizontal, and I was trying to use that just for the flat areas, so I decided to go to scallop. So hit edit, and I got the small tool in there. I did fast contour, and there's my selections right there. Tool center containment, and the 25,000 step over, both ways direction, and I added the smoothing tolerance to kind of shorten the file up and make a better finish. And I left all those alone. So after I did this one, I think we had a pretty good improvement. Simulate. And I'm going to take it right to the end. Give it some simulation time. Other than right there. A bit of blue. So let's change that to, I'm going to change it to the finish contour setting, which really the only difference is step over, this number right here. And okay. Step over is how much, like, just like dancing. And this has got a lot more cuts in it. And let's simulate and hit the home button and go right to the end. Let's see if we get a better looking part here. I was worried about these little triangle areas, but when I watched the full cutting action, it cleaned up. So oh, I think it's getting there. I think it's definitely an improvement. And there it is, gone. So I think this one is pretty close. Only thing was on cycle time, it was starting to get a little bit long. Machining time, 40 minutes. Scalloping alone is 27 minutes. Let's go in and just change this to 0.010. So that should cut it right in half. We'll just have to see how good a finish it leaves. Machining time, now we're down to 26 minutes, so we'll try to see if we can work on some improvements, but let's edit the tool. We'll check our feeds and speeds here. So let's actually bump this feed rate up to 2.5 thousandths. And we're at 10 thousandths and hit OK. I'll have to see if there's any wasted motion. I don't see any. And simulate. And step, drill, right there, and mill. And we'll just go right to the end. right, I think as far as we could tell with this simulation, I think we've got it pretty covered. And let's check cycle time again. Let me close this one up. And machining time is 23 minutes. So we can look at some ways we can improve. Maybe we can, at machine, we can experiment and come up with some different recipes. But as far as if you turn on in your preferences here, and I think I'm going to turn mine back on. Under manufacture is show operation machining time, and it actually will, you can tell right off the bat which ones are taking a lot of time. So that's 11 minutes right there. These are pretty quick. Adaptive, this one is taking a little bit of time there. Right, let's take a look at this one. All right, let's change that to 0.003. That shrinks it up a little bit. This one's at 5, so we're okay there. That's pretty aggressive, but it's a bigger tool. And let's make this one 0.003 also. Okay, and that's now 9 minutes. I think we can probably start there, and then we come up with some formulas that work. And now we're down to 20 minutes. Okay. So now I got to post the code. It's all labeled. And switch machines, classic machine, and post. Save the file, put it on USB, and start machining operation 1. So I got my tool list there. 1, 2, 3, 4, 5, 6. I already renumbered them, so they're in order. And I did my comment line. This has got my comment line with my, so I can pretty much set the job up by looking at this and this, and then take it from there. And all my tool comments. Okay, that's it. We'll cover the operation 2 on part 5.